So it's a ball thrown horizontally at 25 meters per second travels a horizontal distance of 50 meters before hitting the ground. From what height was the ball thrown? So your picture looks like this, right? Well, throw the ball from here. Velocity. What's the velocity?
At 25 meters per second.
25 meters per second. That's all in the x, right?
Yeah.
But we know it doesn't actually follow that exactly. It'll come out here and it'll land somewhere.
Uh-huh.
And this distance is 50 meters.
Mm-hmm.
And you want to find some height.
Yeah.
Okay. So we just have 2 points, right? So we can list our variables at those points. So here you'd have a y, a velocity in x, velocity in y, time, y1 and x1, and a time. And then what does your acceleration look like?
It's going down, right?
So it's just like this, negative 9.8.
Yeah.
So the acceleration in x and an acceleration in y. So what's your acceleration in x going to be?
It's not like 9.8, is it?
Because this is all in y, right?
Okay.
So is there an x component to this acceleration?
No.
No. So acceleration in x is 0. But in y, it's negative 9.8 meters per second squared. And then over here, we've got the same thing. So we have x2, y2, velocity in x2, velocity in y2.
How do you know to write all of these different variables? That's what I don't understand is, because you can think of it and I understand it once you write it, but before that I wouldn't know what I was doing.
So at every point, oops. So you've got 4 things that you want to look at on problems. Acceleration. And then time. So for every problem, you want to find position, velocity, acceleration, and time. And a good way to remember that, just look at this, for example, this kinematic equation. What are the variables that you might need if you wanted to use that equation?
So you need x final.
Yeah, so these are both position.
Mm-hmm.
This is a velocity. Here's acceleration. That's time. So it's those 4 things that you're always working with in these kinematic equations.
Okay.
So you want to at least have, so position you can look at just 1 point. The velocity you can look at 1 point. And the time you can look at 1 point. But you just remember the acceleration is in between. So at every point on your graph, you'll have a position, a velocity, and a time. And in between, you'll have accelerations.
In between the points?
Mm-hmm.
Like literally in between them, in the middle?
Yeah, I mean, it's an acceleration that acts the entire time.
Okay.
So like at this point, we don't know for sure that our velocity is going to be 25 anymore. But we do know that the acceleration will always be negative 9.8 for this whole length.
Okay.
So that's why we draw acceleration kind of in the middle.
Okay.
And then when we get into 2 dimensions, all we do is we say, okay, well, let's just break it up. So we'll have a position in x and a position in y. So that's what we did here, x and y. We'll have a velocity in x, we'll have a velocity in y. So we broke it up into x and y. Time doesn't change with 2 dimensions, right?
Mm-hmm.
So it's just still be time. Acceleration, you can have an acceleration in x and an acceleration in y, so you want to break it up.
But that depends on the direction it's going, right?
Yeah, But you still kind of always want to draw out acceleration in x and y. Because even if it's just straight down, you want to recognize that that's 0.
Okay.
Because, for example, if you just draw this, and you just say, okay, well, acceleration equals negative 9.8. And then you do some equations in the x direction. Is going in this direction only, if you were to use negative 9.8, what would that mean?
Well, that would be wrong because it's not the right direction.
Right. So you're using negative 9.8, that would mean this way, when really it's 0. So even if it's just in one direction, it's good to write. Acceleration x is 0, acceleration y is negative 9.8.
Okay.
So if you forget, if you're thinking about it and you're like, what am I supposed to do? Just write out your kinematic equations, or just think about them and say, well, I need a position, I need velocities, I need accelerations, I need times. And you might not fill in every single one of these equal signs,
Okay.
but it's still useful to know all of them.
Okay.
Like, to know that they're there, that that's what you're working with.
Okay, so then you go back and you fill them in from what you know.
Uh-huh. So let's start up here. So this is just our starting point.
So x1 would be 0,
Uh-huh.
and y1 is going to be, we don't know, right?
Right.
We don't know the height.
And that's what we're trying to solve for. So this right here is a key. That's what we're trying to solve for. That's the answer to our question.
Okay.
Velocity in x.
Going that direction, so that's 25
25.
meters per second.
What about in y?
That would it be the same as acceleration?
So acceleration is a little bit different. This is our initial velocity vector. So this is telling us everything we need to know about the initial velocity. So we could have said this, right? We could have said it's launched at a 30-degree angle. And then if we wanted to find velocity x, we draw the vector out here, right? And we draw the y one like this. This would be vy. This would be vx.
Mm-hmm.
But this one, it's just launched horizontally, right?
Yeah.
So if you break it up, it just becomes vx is the whole length, and there's no vy.
Okay.
So this is our velocity. This is the only thing we want to look at when we're looking at velocity. So we say, oh wow, all of it is in the x direction. There's no y velocity. So we can write that. We say, well, velocity in y is 0.
Okay.
And then time? This is the initial time.
Oh, it's 0.
And then down here, there's a time too. So, okay, what about these ones?
x2 is 50. y2 is 0.
Yep.
Velocity of x.
Well, what will the velocity of x be?
It will be 0.
Has it changed? It started out at 25, and there's no x velocity or x acceleration.
So it will still be 25?
Yeah. So x velocity doesn't change.